I want to go through the fetch cycle in our microcode machine. And first I'm going to show you the machine, and then we're going to actually take a look at the code. We're going to look at how it actually fetches a single instruction. So let's start with just setting up a test. It doesn't matter. The fetch is the same for every instruction, so it's not going to make any difference which instruction, but I'm just going to do a load. And when I do that, then I can step through the different pieces of the fetch. And you can see which lines get turned on and how that happens inside the actual code. So the first thing we notice is as soon as we load that code, it starts out with this blue button up here that says fetch. The way that that happens in the code is if we look at the code itself, we're going to see that the first piece of the code in the microcode is there's a bunch of declarations up here, and the declarations are all the lines that you can turn on and turn off. That's that section right there. And then it says we're going to look at address 0, which is where the microcode starts, and that blue line is this isFetch line right there. So turning that on turns on that little blue line. And you'll notice that at the same time it says that it's going to increment the microcode PC, which is actually one of these lines that it goes to the microcode PC right here. The increment is so that it steps to the next instruction in the microcode. The lines that are turned on is the load line, that's that one right there, to the memory address register. So over here we see that the memory address register's load line is turned on. And it turns on the PC output line. That's the PC register and the output. The output puts the zeros on the bus right here. The load line is going to load it into the memory address register when we step to the next tick. So the first thing that happens in the microcode is it turns on a few lines. Now that's all that the microcode can really do, is turn some things on, turn some things off. It's the control logic. So we're going to step to the next tick. And when we do, what we see is now the address that was in the PC is over here in the memory address register. We look at what's the next set of lines that is going to be turned on and processed. We'll notice that the microcode PC has gone to 1. Remember, we incremented the microcode PC. And we've advanced to the next step. We do the next tick. Okay. At this point, we're beginning to do the read of memory. Okay. So the MDR is going to have an output. Okay. The output for the MDR is kind of an odd thing, but it's got a double buffer here. So it has to have some indication of what it's doing. The memory address register is at 0. We see that in memory we've got, it disassembles it and it says we've got a load instruction right there that's going to get loaded. And the value in the location is hex 1002, which makes some kind of sense. It's a load instruction. That's the 1, and it's from address 2. The hand is 2. So we end up with the load instruction in that register right there. Okay. So we've moved the data from memory to the memory data register. If we look at the microcode itself, we have the different signals we're turning on, the MDR out, the PC inc. Oh, the PC up here, it went from 0 to 1. And the ID memory read, okay, which that line was on a second ago, although I have clicked something and turned it off. And incremented the microcode PC to 2. We step to the next tick. And now we're going to try to take the MDR and put it into the instruction register. So the instruction register has to have a load. the MDR has to have an output. That's the two lines you see turned on. Output and a load to move it. It has to have an output to get it on the bus from the MDR. Okay, and we really want to go to the next instruction in the microcode, so we increment. And then the next one is really important, and we're going to have to spend some time discussing how this actually works. But we'll step to the next tick, and we've got all sorts of things turned on. First of all, it's the first time that we've actually seen things turned on over here with the decoder mux. And we've got control line 1 and control line 0. That gives us a 1-1 in the mux. You see right there is a 1-1 in the mux. We've got MC jump, which is an address value that's going to get loaded into the microcode PC, and it's turned on. So we're taking the 4 bits out of the instruction register at the beginning. The 0001, those 4 bits, we see that its output over here, 0001, and it's being combined with 1 bit from the microcode, MC jump 7, to give us, yes, an address of 88 that's going to get loaded into the microcode PC. So this is how it gets to decoding the instruction. The instruction register to do that has to be turned to output, so that these lines coming out from the instruction register are turned on to the decoder. Some of them are not used, like is0 comes over here and is turned on, but it doesn't make any difference to the decoder because it's not picking that input. It's picking the input 1-1, which is the one we're interested in. The IR decode G1 line is turned on so that we can actually see what these values are displayed out here for us to see. So the next thing is, instead of incrementing to the next address, the microcode PC is loaded. So it's actually going to take the output from the mux, the 88, and load it into the microcode PC, which you can see right there. Which means at the end of this, we've decoded and we've jumped to a specific instruction. So let's look at what happens in that instruction. First of all, we have to have the origin of where the instruction is in memory. And that's an 8-8, which is a 1 3 zeros and a 1 3 zeros. So that's where it's going to be ending up executing next. And this is the set of steps that it's going to run through to actually run this instruction. And I'm giving you 2 instructions. The instruction for a load and a store. And we're going to work through those in detail. And I've also given you the addresses for all the other instructions as it decodes them, which actually turns out to be fairly hard and annoying to get right. So all the instruction addresses are here for all the way through the microcode. Down at the bottom of the microcode file that I'm supplying you is some comments that have, this is how the different instructions work, this is what the opcodes are for the instructions, and also over here there's the ALU. It has the table of what inputs you do in the ALU to get what results as an output from the ALU. So there's some comments that are in there after the end marker in the instructions. But let's go back to load and let's take a look at load. So it's at address 88. There's a comment over here that has it in hex. This is actually in binary right there, 0B. And the load has 3 different things that it does to load from memory into the AC. And this is the execute side of the instruction processing. And again, all it's going to do is turn on a successive number of lines to registers and other components in the system that make it do its operation. So the first thing in a load is we want to take the handout and we want to turn that on. So let's see what happens when we jump to this location. Okay, we are now in the instruction register. The output is turned on, because if we don't turn on the output, we don't get anything from the register. This other handout line is turned on, and that takes the least significant 12 bits of the instruction, adds a 0 to it in the front, and puts that out on the bus. So we see that the instructions 002 is now out here on the bus. We need to take the memory address register, and we need to turn on the load. okay, which is turning on the load right here, so it loads that. We have actually turned off the line that tells us whether we're doing fetch or execute. You notice this went from blue to green and it says execute now. And we're going to increment the microcode PC to the next address, which it's gone from 88 to 89. I'm going to step to the next one. And here's where we take the address, send it to memory. We're going to load this value in memory. Okay. You'll notice that it doesn't know whether that is an instruction or whether that is data. So it decodes it just like it was an instruction and says it's a load 023, but that isn't an instruction. That's just a piece of data with a hex 1230, and that's what memory is reading, because the memory doesn't know or care whether it's instructions or whether it is data. That's showing up in the memory data register. We have to tell the memory that it's a read to do that. And so over here we've got a memory read, and we're incrementing the microcode PC again. We go from 8, 9 to 8A. So it just has the couple lines turned on to make that work. And then we're going to step to the next one, which is we want to transfer the memory data register to the AC to get the value in the AC. What lines do we have to have? We have to tell the memory data register to output its contents onto the bus. So the 1230 now shows up over here on the bus. And the AC has to have a load signal, so it's got a load signal to get the 1230 into the AC register. So what do we see in the microcode instructions? We've got AC load, memory data register output, and we mark this with the end of every instruction needs to have an instruction end. That's that guy right there, to say that's the end of the instruction. And what do we want to do for the next instruction? We want to take the microcode PC and we want to start the next instruction at 0. So we send a clear signal back to the microcode PC and just clear the microcode PC so it'll start the next fetch cycle.